Alright folks, welcome back into another episode with the Mac Surgeon. And today's patient is a MacBook Pro 13-inch 2018-19 model A1989. It came in for their recovery. They take it to a local repair shop. They couldn't do nothing, but the main concern for the customer is get the data. They do not care for the machine. Let's take a look together and see what we can do with this machine without fixing it, get the data if that's possible. All right, we do have our checklist. In our checklist, what we have to do, the unit came in this condition. We have to check it, see if the unit in reality powering on, yes or no. Next step in our checklist, pay attention on right corner. We have to check what kind of power we are getting. Let's plug our power meter, our charger. Okay, we do have a 5 volt and around 400 milliamp on this jumping up and down. This is not good because this could be a case which is related with one of the USB-C controller. Let's check it the other port. Okay, this port is reading only 0.156 amp. And it's stuck there. It's not doing up and down. Let's check the other two ports. This one is doing exact same thing like the other one. Let's check the last one. And this one also is doing same thing. As you can see, the case will be related mainly with the USB-C controller. And today, because they do not care for this unit, they care mainly for the data. So I will try to get the data without fixing this USB-C controller. Let's take a look. Let's remove the bottom cover and check it, see which port is that one. Let's give, oh, even they didn't put, all right. Okay. All right. As you can see, they already removed the battery connection screw on this one. Let me put it back and test it the same way. Okay, the battery is connected. Now let's check one more time, see what kind of power we are getting. Pay attention on the right corner. Disconnect and connect it back in order to enable the battery. This port stuck there. Same reading whatever we had before. This one also is the same thing. Even the battery connected. This one same. This one also is doing the exact same thing. Now there's one thing which is we can try to check it with our multimeter, because we have our checklist, and in our checklist it's by checking what kind of power we are getting. Before I connect it, let's have our multimeter in a volt mode. Black probe into any silver area or any screw hole. That's the ground. The red probe, I will start checking from the fuse. This is one of the fuse. Check it there, and I do not have nothing. All right. Now I have just the 1 volt. Let me plug it back. This one. And we do have a 12 volt, and this jumping up and down as you check on our power meter. Once it goes to 400 milliamp, then it's dropping down and it's doing the cycle. Most likely one of the USB-C controller does have the issue which is doing that. Let's check it with the one which is we are thinking that's the problem. As you can see, with this port we are not getting even 12 volt. If I will check it the other two, we do have our 12 volt and it's doing up and down. Let me check this one too. It's doing up and down. At the same time, if you pay attention, we do have around 400 milliamp. That's too much current drawing for the USB-C port on this kind of machine, on Intel-based machines, because when they are going around 400, they have to switch it from the 5 volt to 20 volt when it's consuming around 200 to 300 max current, and then they have to, in a normal mode, they have to switch it into 20 volt. But right now, as you can see, it's not switching. What I will do, I will try to check, first of all, to find out which controller is that one. Let me unplug the battery. As I mentioned, once you disconnect this cable, the battery is already disabled. Even if there's a juice inside, It isn't gonna do nothing to this motherboard because it's already disabled. This is a very important cable. And I'm talking about the OEM batteries. Sometimes when you use an aftermarket battery, that will be a little bit danger, because even by disconnecting this cable, the battery is still enabled because this chip is not working properly. All right. The battery screw is out. Now let's check it. One of the USB-C controller, that PD controller, which is this one, because we do have the problem on this side. By having multimeter in a on mode, let me bring the microscope. This is our USB-C controller, one of the USB-C controller. Just I like to check, see if the malfunctioning one is this one or no. There's also easy route. We can do it with a schematic. I'll show you that one too. All right. The component, which is whenever you have a USB-C controller, it's easy always to check it rounding big caps. As you can see, we are reading around 100 ohm. That's enough. That's not a problem. Let's check the other one. Oh, here we are. We do have a 17 ohm. This is our malfunctioning USB-C controller. Let me check also this one. As you can see, we do have around 0.5 kilo ohm, which is 500 ohm. At the same time, I wanted to show you the working one when you are checking what kind of reading you are getting. One of the other working USB-C controller, it's on the right side, and the other two are under the board. Let's check it here and see what we are getting. As you can see, we are getting around 3 kilo ohm. It's going up. This one, we do have a 22 kilo ohm. And let me check this one. And we have here 0.5 kilo ohm. But at the same time, let me double check here. Here you can see we do have a 1 ohm. That's enough. It's almost 0 ohm because my probe, when I am shorting together, I'm getting 1 point something ohm. And let's check again. You can see we do have a 17 ohm. This is not normal. What that is telling me, we do have an issue with this controller. This is a controller which is causing all the problem. But I wanted to show you one more thing. If you wanted to go more advanced option, these are the basic stuff for someone who wanted to learn how to do diagnostic. Let me open the board view and I will show you what part I'm talking. All right, this is our board view. As you remember, the one which is we was checking was malfunctioning. It was malfunctioning this side. And the port, check again over there, it's this one, close to the screen. Now let's go in our board view. This is the CPU and we was looking here, this one. This is a 20 volt PP bus and let's check it where it goes. There's no connection with this controller. And it goes to here, to this controller. This is a U3200 CD 3215 USB-C controller, and the shorting part was this one, the PP3V3 UPC XBLDO power rail, which is generated from this USB-C controller. Once I remove this controller, that means this unit will be okay. But I wanted to show you one more thing, confirming 100% if this is the controller is doing. That I will take it with the thermal camera. Here, this is the controller. Check it here. I will plug it the power supply, actually our charging cable. Right away it gets hot. I will connect it now the next port, which was consuming 400. As you can see, we already confirmed our problem is coming from this USB-C port. Now we do have two options in order to get the data from this unit. Either we have to fix the unit and get the data, or there's also another option, which is we can try it and see if we can if we can boot the machine and get the data. I will choose a second option because everybody can remove the chip and replace it with another one, but at the same time I wanted to pay attention. These controllers you have to use either from the donor board, or you can use it again from donor board, but it should not be exact same one. It can be used also from A1990. which are compatible. Except of these two units, you cannot use any other motherboard to transfer the chip because it won't work. It does have a firmware inside. Right now, let's say someone is short from the chip and he wanted to get the data without fixing the unit. Let's go and start doing this process. Here I do have a device, and this is a very nice and cool device for the battery. So what does do this device? We will be able to charge the battery externally without using the computer. Here we are. This is our cable. It does have also polarity, as you can see on here. We do have positive and negative. Always you have to be very careful when you are connecting. Now, this battery, it's completely disabled because this cable is not connected. Even if I will short it, nothing gonna happen. But let's check one more thing. I'll bring it to your attention, my power supply. Now let me connect it. Here I do have a OS red, it's my ground. And OS black, I do have my positive. Now it's the time to enable our device. How we can enable it? Our not the device, now we have to enable our battery. Let me plug it this cable. This is the other cable. All right, our device is enabled. Okay, what it does says here, as you can see, it says MBRT menu, then the pack info, unseal, repair set, edit, data flash, and battery status. I will go unseal it and get the pack info. And here is telling me everything about this battery, the serial number you can see on the bottom, then there are the manufacturing date, the capacity, and all the rest, but the battery health and everything. Right now our cells are completely discharged. So what we have to do, we have to charge the battery externally. Let's try to charge it. I will have my power supply like 10 volt, and I will bring it the current maximum 1 amp. As you can see right now, we do have a here the output is the green, which is it dropped around 9 volt, and at the same time you can check it in the left corner here. Our cells are charging and it goes up. Now we have like 10 volt, and then there will be always stable 10 volt. But what I can do, I can try to increase it a little bit now more by making 11 volt, and at the same time I can increase also our current. Now it's charging here. This is our current, which is around 2 amp, and it goes down, which is also normal because it will reach around 11 volt. Now I will increase it also our volt. And you will see it jumps again up. Now I can change the volt again into 12 volt. And now you can see our maximum current was set into 4 amp, but because it reached already our battery voltage is around 11.2, this one. Now I can go a little bit more higher the voltage, which will be our max. You cannot go more than this, like 12.3 is enough. Even now if I will increase the current, nothing gonna happen because this unit does not need more than, how much is it here, around like 2.8 or so. Yeah, you can see there the current right now which is consuming, it's a 2.8 2880 something. and it will start dropping slowly, going down all the way. This graph will come close to zero once it's fully charged. And our voltage, it's here with 12 volt and 12.3 volt. This is our setup, and I will keep it like this for a little bit so the unit can charge, and then I will try to boot the machine without using the USB-C controller, so trying to get the data.
A few moments later.
All right, now it's charging quite a bit, and we already have like 4% of the batteries. Check it here in the corner. What I can do just to make sure by doing this if this unit will turn it on, yes or no, if it will boot it, I'll try to connect it and activate the battery, so checking if this unit will boot. Yes. Let me remove all the cables. Turning off our battery power supply. And here, once I remove this cable, it will automatically disconnect the battery and the battery will be disabled. Alright, battery is connected. Let me plug the charging cable and check it, see what's happening. Now, as you remember, this port was completely gone, but pay attention on our right corner, see what's happening with the charger. Now we do have a 5 volt. If I will remove it and put it back, it's stuck to 0, and then to 20 volt, and it starts charging. Let's check it, see if it's here. As you can see, we do have also the Apple logo. This unit is on. There's one thing which is, let me show this one too. Right now, if I will disconnect it and get into this, it starts charging. But we have a problem here because that chip is overheating. Check it here. All right, check the volt. Normally we should have there like 3.3 volt. Check it here. We have only 3 volt. And now check the thermal imaging. See? If I will disconnect it, it still stays there hot because that chip is malfunctioning. That's the reason. All right, folks, this was another lovely case. We was able to save patient's memories. Customer is happy, I'm happy, patient kind of happy because the patient is not fully survived until the point when the battery will be completely discharged, and at that moment this unit will not turn it on anymore. So I hope you enjoy it and you learned something new, and don't forget to share, subscribe and comment. In case if you have any question, you can leave in the comment section. I will try to answer your questions, and I'll see you next time. Bye bye.